Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to solve equations involving radical expressions. Now to do this, you'll need all of the skills that you've learned in the previous videos in this topic. That is simplifying radical expressions, often adding or subtracting radical expressions, and then applying exponent rules to radical expressions. Okay. Now, how do you solve an equation involving radical expressions? So what we need to do first is you want to isolate a radical expression on one side of the equation. So if you only have, for instance, one radical expression, move that to one side of the equation, move all of the other terms to the other. If you have more than one radical expression, then you want to move one to one side of the equation and then move all of the other terms to the other. What you'll do then is you'll raise both sides of the equation to the index of the radical. So if you have square roots, once you have that square root on one side, you would square both sides. If you had cube roots, you would cube both sides. Okay. If you only had one radical expression to begin with, once you've completed step 2, you should no longer have any radical expressions. So then what you'll do is you'll solve the resulting equation. If you had more than one radical expression, you'll still have a radical expression left over. So what you want to do is then go back to step 1. Isolate the radical expression you have remaining on one side of the equation, and then repeat step 2. Once you've solved the resulting equation, you've eliminated all radicals and solved, check your solutions. You can end up with solutions that with sort of things that you have solved for that will not solve the original equation. We call extraneous solutions. So check your work at the end. Here's our first example. So our first step always, we want to isolate the radical on one side of the equation. So we can start by subtracting 3 from both sides of the equation, and we'll have the fourth root of 2x minus 5 equals negative 2. Now we actually are done here, and the reason why is the fourth root of a number cannot be a negative number. If we have the positive fourth root here, then we should have a positive number here. Now, I'll show you what I mean though. If we did continue with this problem, you would raise both sides to the fourth power. You would have 2x minus 5 equals negative 2 to the fourth is 16. And if you solve this, right, we add 5 to both sides. You get 2x equals 21, divide both sides by 2, and we get that x is 21 over 2. If we were to plug that in back into our original equation, we would have the fourth root of 2 times 21 over 2 would be 21. So we'd have 21 minus 5 here. So when we simplified this, we would get the fourth root of 16, which is 2. We get 2 plus 3. We would actually get 5 equals 1, which is incorrect. So this was not a solution. So this is no solution to this problem. And again, you can actually have stopped this much earlier once you're here, because again, if you have the positive fourth root, that cannot be a negative number. Anyway, that's it. So make sure you're careful. Make sure you check your work at the end in case you miss this, because it's very common, you're doing the problem to just sort of keep going through the steps and you don't realize at the end that what you got was not a solution. Example 2. Now we don't have a radical expression in this equation, but we do have a 1/5 power. So we could simply rewrite that 1/5 power as the fifth root of 5x plus 2. Not necessary, but if you feel like it, go on ahead. The next step is to isolate the radical expression on one side of the equation. So I'm going to do that by adding it to both sides of the equation and subtracting 1 from both sides. So we end up with 2 equals the fifth root of 5x plus 2. And now I raise both sides of the equation to the fifth power to offset the fifth root. So I get 2 to the fifth equals the fifth root of 5x plus 2 to the fifth. On the left-hand side, I get 32. On the right-hand side, the fifth root and the fifth power cancel, leaving me with 5x plus 2. And now I simply solve this. I'll get 30 equals 5x. And then we divide both sides by 5. And our final answer is x equals 6. Now, important thing we want to do is check is this a solution of the original equation? If I plugged in x equals 6 here, either this one or this one, we get 3 minus, so we get 30 plus 2 here. So we get 3 minus the fifth root of 32. Well, the fifth root of 32 is 2. So we get 3 minus 2 is 1. That checks out. So this is our solution. Here's our final example. We want to solve this equation. The square root of 7 minus x equals x minus 1. So we already have the radical expression isolated on one side of the equation. It's the only term on one side of the equation. So we can start by squaring both sides of the equation to remove the radical expression. So on the left-hand side, we get 7 minus x. On the right-hand side, we just need to expand that binomial squared. So if we do that, we'll get x squared minus 2x plus 1. Now we have a quadratic equation. So we need to move, for quadratic equations, we want to move all of the terms to one side. So I'm going to subtract 7 from both sides. And I'm going to add x to both sides. So we end up with 0 equals x squared minus x minus 6. And that will factor. We'll end up with x minus 3 times x plus 2. Now this equation will have two solutions then, right? Because if I have a product of two numbers, x minus 3 times x plus 2, if that product equals 0, one of them has to be 0. So either x is equal to 3 or negative 2. Now the final thing we have to do is we have to plug these in to the original equation and see, are these solutions? If I plug in x equals 3, I will get the square root of 7 minus 3, so that will give me 2, right? It's the square root of 4. And then over here, I'll get 3 minus 1, that will also be 2. So that one works. Okay, so 3 is good. Now, if I plug in negative 2 here, I will get 7 minus negative 2. So that'll be the square root of 9. That should be 3. However, on the right-hand side of the equation, I'll get negative 2 minus 1. That will give me negative 3. So in other words, if I plugged in negative 2, I would get 3 equals negative 3. That is not true. Therefore, negative 2 is not a solution to this equation. So you want to throw that out. So the only solution to this equation is x equals 3. And that's it for solving rational or radical equations. Now, this will use a lot of the skills you've learned. So if you're having trouble simplifying some of these radical expressions, maybe go back and practice in some of the other videos in this topic. But in any case, though, it'll take some practice to get this mastered. All right, until next time, have fun.